Okay, so let's get started with 7.2 part 2. Okay, so I have some slides that are going to show if you want to do it by hand, but we're going to do StatCrunch. So let's grab everything that we need from this slide. So it says in auto racing, a pit stop is where a racing vehicle stops for new tires, fuel, repairs, and other mechanical adjustments. The efficiency of a pit crew that makes these adjustments can affect the outcome of a race. A pit crew claims that its mean pit stop time is less than 13 seconds. A random sample of 32 pit stop times has a sample mean of 12.9 seconds. Assume the population standard deviation is 0.19 seconds. Is there any evidence to support the claim if our level of significance alpha is equal to 0.01? All right, so a lot going on there. Let's break it down. So first it said a pit crew claims that its mean pit stop time is less than 13 seconds. Okay, so we know we're going to have a null hypothesis and an alternative hypothesis. We did this in 7.1, and this is less than. So since it's less than, we are going to have to put it in the alternative. Remember, the equal to has to be in the null. So my claim is going to go in the alternative. I've got that my mean is less than 13, and that means that here I have a mean of greater than or equal to 13, right? Those have to be complements. And then let's just see everything else they gave me. They told me that n was 32, that's my sample size. My sample mean is 12.9. My population standard deviation is 0.19. And then finally, alpha is equal to 0.01. So this is all the information I'm going to need to put all of this into StatCrunch. Okay, so I just wanted to show this slide in case you want to do this by hand. I'm going to talk about StatCrunch. You would have to find Z first, and then once you find Z, you would have to go into the normal calculator and find your area P. Okay, we do know we have a left tail test, and that's because our alternative is pointing to the left. It's great, it's less than or equal to. So let's head to StatCrunch. Okay, so we are going to go into Z-stats because we know sigma. They gave us sigma. We're going to go to one sample with summary. This is a lot like the confidence interval. We're going to put in our sample mean, our standard deviation, our sample size, but this time we're going to do hypothesis testing. Now, the weird thing about StatCrunch is it always has an equal sign for null hypothesis. I don't know why. And so what you have to do is put the alternative in correctly. So our alternative is less than 13. We're going to put the 13 here and the less than here. When we do that, StatCrunch is going to do all the work for us because we asked for a hypothesis test. And so it's going to give us the p-value here. All right, so let's think about this. Our p-value is 0.0015. This is very, very tiny. Our alpha is 1%, 0.01. And so the issue is that our p-value is very tiny and it's less than our significance level of 1%, and therefore we're going to reject H naught. Okay, we're going to reject the null hypothesis. Of course, by rejecting the null hypothesis, remember our claim was on the second, was on the alternative. So if we rejected the null hypothesis, that means that we're able to support the claim. And we're going to keep doing more of looking at that wording. All right, so let's look at another problem. We have, we're looking at a study of US homes that use heating equipment. The mean indoor temperature during winter is 68.3 Fahrenheit. You think this information is incorrect, and so you randomly select 25 homes and use them, and you see that the sample mean is 67.2 degrees Fahrenheit. And then from past studies, you know that the population standard deviation is 3.5 degrees Fahrenheit and that the population is normally distributed. We needed to see that because the sample size is less than 30, it's 25. So we want to know if there's enough evidence to support the claim based on our significance level being 5%, 0.05. So let's take a look real quick. Let's set up our alternative and our hypothesis. Our null hypothesis and alternative. So it says that the mean temperature is 68.3. That means we can put that here, right? Because it's the equal sign. The alternative would be not equal to 68.3. And we're claiming that the 68.3 is incorrect. So our claim is going to be here on the alternative. Okay, so we have lots of information. We have our sample size is 25. Our sample mean is 67.2. Our population standard deviation is 3.5. And finally, our alpha is 0.05. So we can now go to StatCrunch. We have everything we need to know. And since we have a standard deviation, population standard deviation, we can go to ZStat. I did want to show you this page. If you're not going to use StatCrunch, you would have to find the z-score and then go into calculator normal and find your p-value that way. You would have to, this is a two-tailed test, and so you'd have to do calculator normal twice. But let's use StatCrunch. This is just the rest of the slide. If you're going to do it by hand, you would have to find the area for both ends and add them together and then compare them to the alpha. Okay, let's take a look at if we're going to use StatCrunch. So we're going to go to ZStat. That's because we have our population standard deviation. We're going to do one sample with summary. We're going to put in all of our information, the sample mean, the population standard deviation, the sample size. We're going to set up our hypothesis test. We've got a not equal to in the alternative, and we have 68.3 as the mean. Okay, at that point, you're going to hit compute, and you're going to get a very large p-value here. All right, so p is 0.1161. That is very big. And when we compare that to our alpha, it is greater than our alpha of 5%. And so we do have data values that are in the do not reject area. Therefore, since the p is greater than the alpha, there is not enough evidence to reject the null hypothesis. Now, the issue is our claim was in the alternative. Well, if we do not reject the null hypothesis, then we can't support our claim, right? It's one or the other. And so based on our information, we cannot support the claim that we think this data is incorrect. Okay, so let's look again at this idea of a rejection region. I talked about a little bit in part one. So if this is our alpha here, that is what we call our rejection region. And so if our area for P is contained inside this rejection region, so if it's just right here, then we're going to reject, because we don't have any data values that are in our do not rejection region. But if we have a rejection region here, So that's our alpha. And our p-value comes all the way out here, then we are going to not reject, because we do have some of our data over here in the area that is not the rejection region. Okay, so the p-value has to be contained, like this side has to be contained completely in the rejection region in order for us to reject H naught, our null hypothesis. And so our critical value here, our z-score right here, is what separates the rejection region on the left from the do not reject from the right. And the same thing works with the others. Now with the two-tailed test, the rejection region is going to be on each side, and the area in the middle is the do not reject. So this would be the do not reject DNR. Each end would be the rejection region.